Prepare for a cosmic upheaval of unimaginable scale. Betelgeuse, the massive red giant star on the outskirts of our galaxy, is emitting unsettling signals across the cosmos. Observations from the James Webb Space Telescope have revealed something deeply disturbing about this colossal celestial entity. As renowned astrophysicist Brian Cox delivers a serious warning, one question looms large. Are we on the brink of witnessing a supernova explosion that could permanently alter the night sky? In the vast expanse of the universe, where stars are born, evolve, and ultimately meet their end in spectacular ways, one particular star has recently captured the fascination and concern of both scientists and the public. This star is Betelgeuse, an enormous and ancient red supergiant located prominently in the constellation Orion. Its distinct reddish glow and fluctuating brightness have long intrigued astronomers, but recent observations have intensified interest in this cosmic giant. As we delve into the nature of Betelgeuse, we stand at the threshold of a potentially momentous event in its life cycle. But what do these recent changes indicate? Are we witnessing the prelude to a celestial spectacle of unfathomable magnitude? The immense scale of Betelgeuse. Betelgeuse, roughly 764 times the size of our Sun, is a behemoth among stars. Its immense scale is almost beyond comprehension. If it were to replace our Sun, its surface would extend past the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars within its fiery embrace. This staggering size not only highlights its physical enormity, but also marks its late stage in stellar evolution. As a red supergiant, Betelgeuse is in the final chapters of its existence, a period characterized by expansion and cooling after millions of years of nuclear fusion. Despite its colossal size, Betelgeuse is relatively young by stellar standards. Estimated to be between 8 and 8.5 million years old, it is ancient in cosmic terms yet youthful compared to the universe's longest-lived stars. Its transition into the red supergiant phase signals the culmination of millions of years of evolution, transforming from a hot blue star into the dimming red giant we see today. The life cycle of Betelgeuse. The life cycle of massive stars like Betelgeuse is a tale of continuous transformation, dictated by the forces of nuclear fusion and gravity. Its signature red hue is a key indicator of its current phase. The color results from its cooler surface temperature compared to stars like our Sun. While the Sun's surface temperature is about 5,500 Kelvin, Betelgeuse's outer layers are significantly cooler at approximately 3,500 Kelvin, giving it its distinctive reddish glow. However, this coloration is more than just a visual trait. It provides valuable insights into the star's physical state and the processes unfolding within its vast gaseous body. Adding to Betelgeuse's intrigue is its historical color shift. Records from ancient Roman and Chinese astronomers suggest that around 2,000 years ago, Betelgeuse appeared yellow. It wasn't until the 9th century that Arabic scholars began describing it as red. This transformation, documented over centuries, is a crucial clue in unraveling the star's evolutionary journey. Betelgeuse's unusual behavior. Betelgeuse's fluctuating brightness is another compelling aspect. It is classified as a semi-regular variable star, meaning its luminosity waxes and wanes in complex cycles. Typically, it follows a 400-day cycle, accompanied by a longer one spanning roughly 5 years. These fluctuations have been recorded as early as 1836 by astronomer Sir John Herschel, and possibly even earlier in indigenous oral traditions. However, what sets Betelgeuse apart from other variable stars is its unpredictability. Unlike stars that follow a consistent brightening and dimming pattern, Betelgeuse sometimes deviates from its expected behavior, hinting at mysterious and little understood processes occurring within its massive form. The Great Dimming Event. A recent unprecedented event thrust Betelgeuse into the astronomical spotlight, the Great Dimming. In late 2019, the star, normally one of the brightest in the night sky, began to fade dramatically. By February 2020, it had dimmed so significantly that even casual observers could notice the difference. Its brightness plummeted at an average rate of 0.01 magnitudes per day, raising urgent questions about what was happening to the giant star. Yet, studying Betelgeuse presents a fundamental challenge, what astronomers call the time paradox. When we observe a distant star, we are not seeing it as it exists today but as it was when the light left it. Given that Betelgeuse is about 725 light-years away, the light reaching us now actually started its journey nearly 7 centuries ago. This delay makes real-time monitoring of sudden stellar changes incredibly difficult, as we are essentially looking into the past. Understanding the mystery. The dimming of Betelgeuse underscored these observational challenges and highlighted the complexities of studying massive stars on cosmic timescales. The event was closely monitored by Andrea Dupree, Associate Director of the Center for Astrophysics at Harvard and Smithsonian, and her team. Using the Hubble Space Telescope, they conducted a 3-year study tracking fluctuations in the star's outer atmosphere. These observations provided critical insights into the behavior of a variable star like Betelgeuse, which regularly expands and contracts, causing its brightness to change. Hubble's ultraviolet sensitivity enabled scientists to examine the layers above the star's surface, which are influenced by turbulent convection processes. By analyzing spectral data from 2019 and 2020, the researchers detected material moving away from Betelgeuse's surface at staggering speeds of nearly 200,000 miles per hour. This ejected hot, dense material extended millions of miles outward, eventually forming the dust cloud responsible for the star's dimming. What lies ahead for Betelgeuse? Dupree and her team estimated that Betelgeuse lost roughly twice the normal amount of material from its southern hemisphere over 3 months. Such mass loss is not unusual for red supergiants, but this particular event was extraordinary in its scale. The vast ejection of material and the subsequent dimming led to speculation about whether Betelgeuse was nearing the final phase of its life, possibly a precursor to a supernova explosion. Because Betelgeuse is relatively close to Earth, any supernova it produces would be an extraordinary astronomical event, visible even during the daytime and offering an unprecedented opportunity to study a stellar explosion up close. However, scientists remain divided on whether the great dimming signified the star's imminent demise or was simply a temporary episode in its complex evolution. The magnitude of this event was staggering. Betelgeuse expelled an estimated 400 billion times the mass typically released in a solar coronal mass ejection. The ejected material, comparable in mass to several moons, was a striking testament to the star's turbulent final phase. But what does this massive outburst mean for Betelgeuse's future? And what are the broader implications for supernova predictions? The answers could reshape our understanding of how massive stars evolve and ultimately explode. The prospect of Betelgeuse going supernova is both thrilling and scientifically invaluable. If it were to explode, the resulting burst of light would briefly make it one of the brightest objects in our sky, rivaling the moon in luminosity. Scientists would have an unprecedented opportunity